Hello ladies and gentlemen, and welcome back to the channel. This is the second episode of the rebuilding of a Porsche 935. Come along with me. Hello, I'm Hax. I'm a filmmaker and a storyteller. I love to travel, meet fascinating people, go to interesting places and discover amazing things. Come along with me as I search for the fascinating, the interesting and the amazing. Hello, and as I said, it's the second episode to building the 935 Porsche with William Hardy. He's there he is, okay. Now, for those of you who have not seen the first episode, the link is just up there. Take that and have a watch of that first, and then come back to this one. Now, the way YouTube actually runs a channel and also playlists, this series is actually in a specific playlist. I know that it serves up individual videos, so you might be seeing this quite randomly. But if you are, take a look at the first episode and have a look at the playlists in this channel. So William, give us a quick recap. What are we looking at?
Well, we're looking at a Porsche 935. It's a derivative of a Porsche 911, but it's a race car. It was a normal road car, which was slowly converted by the gentleman who owned it prior. It had the stickers, it had the spoiler, had the rear arches, these quite large fiberglass arches. But we've taken it to the next level. So we've stripped it down to a complete shell, added roll bars, done lots of modifications to the suspension, well, the engine bay region, the front compartment, even the roof. There was a sunroof on there, which is now gone. So we've rebuilt all of it, and now, it's beginning to look like a car. So it's rolling now, which is good, like quite literally rolling. So we're awaiting the gearbox, waiting the engine to come back. We can then get that in and start getting it ready for the road or the racetrack. Yeah.
Now, it was about, 6 weeks ago that I was here? And it was literally just the shell with the frame and everything like that. And you've now added quite a bit. Take us through the first project.
The first project was to get all the main suspension assembly on. So I rebuilt all four corners, one piece at a time. And I was actually marrying those to the car. That was the first job, which sounded quite easy. And because I'd prepared them as much as I could have done, I thought it would have been a case of just putting them on, but that wasn't the case. There were certain areas of the front end, because we have a completely different system on the front end now. We had to get certain bits on the car machined, and also bits of the new subframe machined. So that was a challenge. The back of the car, the 935 camber boxes, which are where these trailing arms pick up, they were actually slightly narrow, so we had to basically widen those. But as I say, they now accommodate the trailing arms, and they'll work effectively, which is good.
One of the things that impressed me last time was the fact that you had to put it on a jig and get it quite positioned, or get it positioned very accurately, so that you could fit the pieces, and when they actually operated at various camber angles, I guess, yes. It would all snug together. Would you talk us through that a bit?
So the car had to go onto a jig. So these new pickup points are absolutely perfect. And when we have 3 degrees of negative camber on this wheel and 3 degrees negative camber on that wheel, then the whole car will sit basically straight, and it will. What I'm trying to say is you need a perfect car and all the suspension pickups to be perfect. So when we do the geometry, the car will work as we suspect it to. Because if the hub, this section here, the whole hub is saying one thing, but it's bolted to something that's not correct, it's not going to work correctly with this one, and it's not going to work correctly with the front two.
And so what are the suspension? What's so special about this particular suspension setup?
This particular suspension setup now uses a McPherson strut, which is this. It's a coil, which is the blue, blue coil here, coil spring over a damper. It's modern. Previously, this Porsche had a damper here, and then in that tube, which runs at the back of the engine bay on the bulkhead, it had a torsion bar. So a torsion bar and a damper, it worked effectively, but you're very limited to how you can set that system up. So what we've done is we've completely removed the torsion bar, and we're just relying solely on this coilover system. But by doing that, we can change the ride height using these rings here. We can change the damper spring rate. We can change the springs. We've basically given ourselves a lot more scope, and from that we can make a car better handling and ultimately faster. Done the same for the front as well. So the front was a torsion bar and damper, but we have now got a coilover system. And again, we can do exactly the same on the rear, on the front, and with the benefit of a adjustable roll bar, which we've got front and rear, we can fine tune it even more. So it's modern suspension on a car which was produced in 1979.
You started saying something about roll bars. I'm not quite sure that I actually understand that.
So this the front suspension is completely different to the standard 911. First of all, we've added, if I pull around the suspension, we've got a completely different subframe system. So this is actually effectively a Porsche 997 GT3 front system, which has been modified and adapted to fit an early 911. So it's all aluminium system with ball joints. So there's no rubber bushings. It's all nice ball joints. We've also added a RSR style roll bar system, which was probably one of the most special modifications for the front end here. Road going 911s of this era do not have this system. They've got a much more generic roll bar system which will run under the car and is not adjustable. We've also gone for the coilover system here. So normally this would be just a shock, and then the torsion bar would run just down here like so. But we've got rid of all of that, and we've got a modern McPherson strut, which is fully adjustable, just like the rear of the car. So with this and all of the ball joint lower wishbones and whatnot, it'll make it like a pin sharp sort of car to drive, and you can set up just as you need. So we've obviously got a lot more weight in the front with 100 litres, so we can soften the dampers to make that easier to drive and to make it faster or slower, depending on how you want the car to react. We've basically made the scope of adjustment a much bigger window to play with.
Now, you mentioned just now that these were quite special tyres. They're not ordinary tyres. Tell me more a little bit about your approach to the tyres.
So the original tyres, original wheels and tyres on a 935 were very unusual sizes. So some of the cars had 16-inch front wheels and then had 19-inch rears. Unfortunately, tyre manufacturers don't actually produce those tyres anymore. So what we've done is we're going to go for either a 16-inch or a 17-inch on the front and then an 18-inch on the rear. Reason being is tyre manufacturers still produce and give you plenty of option of tyre. We want to go for a staggered setup. Staggered means larger on the rear and smaller on the front, because obviously the 935s did run staggered sizes. Some people just opt for running 17 all round or 18 all round, but we're trying to sort of keep it as sort of original as we can with regards to the size of the wheels. The appearance of the car is as important as it drives, really. What do you think it is anyway? So that's yet to be decided, 16 or 17, and the offset means how the wheel sits in relation to the car, so how close it's going to be to that strut there. You know, is it going to foul on the inside of the arch here? Is it going to hit the wing? All of that is yet to be calculated. We've done it for the rear, hence why we've got space savers on the back of the car at the moment, because we're having the rims manufactured, which should take about 5 weeks, and then they'll be here and I can put them on.
Whilst we're at this side of the car, tell us or talk us through, you showed me where it was all going to go, but the air jack system?
Yes, so the air jack system, which is mounted here, that will be on a cable of air, and there'll be about 30 bar of pressure in there. So during the pits, the car will come down the pit road. Obviously, all your mechanics, engineers will be ready, and in order to change the tyres, we need the car in the air, rather like it is now, but obviously with this jack. So instead of putting 4 jacks under the car, what you'll do is you'll run over to the car, fire that on there, the car will then raise up, and you can take the wheels off, and by pulling on that there and coming back off, the car will then extinguish all of the pressure, drop down onto the ground, and then you can carry on with your race.
The air jack is actually in this column, isn't it?
Yes, so it's behind this section here. We haven't actually got this air jack fitted at the moment, but if you just look over there, that is mounted just here. So it's just the other side of this roll, part of roll cage, and it's tucked all the way in here. So it's nice and safe, out of harm's way. What it also means is when the wheel is turned full lock left, the tyre is not going to hit here because it's the other side of this panel. A lot of cars I've seen online, which people have built over the last 40 years, if people have put the air jack in the wheel arch, then you've basically just shortened your steering angle a lot, because there's a big air jack sitting there. So I've housed them in here, basically, so we've got a lot more room in the arch to play with.
I have to say, leaning into the car now, I've just seen your pedal arrangement, and you said that you'd spent quite a bit of time working that all out. It looks like an ordinary car arrangement, but obviously it's not.
Some cars will have pedals like this, but all of these pedals, they go down like that. It's quite normal that your throttle pedal will go down like that, but your brake pedals go up into the dashboard. But on a race car, a normal race car, we have a pedal arrangement like this, so they're all the same, so they basically go down this way. So you've got your throttle, you've got your brake, and then you've got your clutch. On a normal 911, this throttle is actually a mechanical linkage, but where we've moved the pedal arrangement and done so many modifications to the engine, we're now using a fly-by-wire system, which is basically an electronic throttle. So there's no mechanical linkage there. That also means you can set it up so you can have driving modes. So if you want a nice, slow, sort of methodical, lazy driving mode, you can have the throttle response very slow. Whereas if you're on the circuit, you want it as quick as possible. But because we've got a fly-by-wire, it's electronic, so we can set them up however we want. So there will be multiple driving modes on this car, which is another sort of exciting thing to look forward to.
And then again, right in front of me is the gear shift. And you said that you made it closer or longer because the driver or the owner is actually quite tall?
So the original position of the gear stick was down here, and it was about 7 inches forward. Now, the owner of the car and the person who will be racing it, he's very tall, so we've actually moved the seat position back around about 12 inches to here. If we had the gear stick in the original position, he wouldn't actually be able to reach the gear stick comfortably. So what I've done is I've moved it back and up. And if the steering wheel sits around about there, your hand is right next to the gear stick. So it means that you can go from the gear stick to the steering wheel really quickly, which is obviously ideal in a race car. Not so much on a road car. But the idea was to get that as close to the steering wheel, but also as comfortable as it could be in regards to the driver. So, easy as it sounds, it wasn't, because by doing that, we've had to create a completely different linkage system, which obviously connects the gear stick to the gearbox. So what you're looking at here is the new gear linkage, which works with the repositioned gear shifter. So originally, the gear linkage was just a solid straight bar, which was about 7 inches longer. What we've had to do is shorten the linkage to this length, but also raise it so it works perfectly with the newly positioned shifter. The principle's very easy, actually machining everything, getting linkages to work so you can get all 4 gears and reverse was quite tricky, but that there is the linkage for the car. Again, couldn't begin to think how many hours of trial and error that took and machining, but there is your linkage.
So what was the main thing you learned about doing that exercise?
If you had tens of thousands of pounds and computer systems that could do it for you, it would be a lot quicker. But also patience. Anything is possible if you put your mind to it. It looks very simple, but yeah, anything is possible. If you want to move something, you can move it, but obviously it has to still function, it has to still work, and you have to make new bits and pieces so it does work, and this was one of those pieces.
And I guess working under duress as well, under race conditions.
Yeah, I've designed it so everything is functional, but also if we actually look in the car, I've made an inspection panel there, so if anything does go wrong, we can actually diagnose or rectify it. It's all good having a system that works, but if it's not serviceable, if you can't get parts to replace damaged bits and pieces, then it's not going to be an effective race car. So everything we've done, you aim to make it serviceable.
I notice now that the front to the car, which you said in the first film was a fiberglass continuous piece?
Yes, so we call it a one-piece clip. So the whole front end is one piece, so the front wings and the bumper are all one piece. The reason they did that was so you could gain access to everything very quickly. That's also got its drawbacks, because if you have an accident on the track, if you damage this section here, it's not a case of just replacing this section, you have to replace the whole thing. This was created from a genuine 935 mould. It wasn't cheap, and to be honest, the fit's not fantastic, but it was a mould from the 1970s and 80s. I think what a lot of people forget is if you're paying a lot of money for a product which was designed back then, it's not going to be as well finished and presented as products today. So the gap here, for example, is not fantastic, but it's a race car from the 70s, or it will appear to be.
What I've noticed as well is that you've got grills right over the tyres, and then you've put a wire mesh on the air intake. And if I remember rightly, there's an is that an oil cooler behind there?
Yes. So the car runs 3 oil cooler radiators. So the air will come in here, it will go through the radiator, come through these ducts here, and then there is actually another oil cooler just inside this wheel arch, and then all that turbulent air will come out through these grills. There's also a section of grills here, and also on the wheel, the face of the wheel, there will be, some people call them turbo fans or wheel fans. It's basically a fan which will help draw hot air out of the wheel arch, because you don't want to build up a turbulent air, because at speeds of 200 miles an hour, turbulent air in all the wheel arches will really unsettle the car. So it's good to get as much air as you can out of the wheel arch. So you just worry about the air on top of the car, so it keeps the car stable.
And that's a clip-on, almost like a wheel cover, yeah?
Yeah. So what I've done is I've got extra long wheel studs here, so we can bolt the wheel on. And we've also got enough stud to basically put a cover on and also get a nice thin shallow nut and then put 5 nuts on to hold the wheel fan on. So it's not going to be, you know, the nuts holding the fan on aren't going to obviously be holding the wheel on as well. There'll be two separate wheel nuts. The fuel cell, you see, sits right here. It's the largest fuel cell I could get, which is 100 litres. The next step is to mount what's called a swell pot. So the fuel tank is here and the engine is at the back of the car. Now, it's quite common in high performance vehicles that the engine actually uses more fuel than the pump can deliver. So what you have is it's called a swell pot, and we're going to have 2 swell pots, and the pot is going to be 1 litre each, so there'll be 2 litres of fuel. And what a swell pot does is it keeps 2 litres in our case of fuel right next to the engine. So when we require lots of fuel under a heavy acceleration, the fuel is there, primed, ready to go. If we're just on the road driving normally, then the fuel pumps, which are here, this side of the car, will be able to keep up with the fuel demand. But that's the next step in the fuel system, working out where I'm going to put the swell pots. The problem I've got is I don't have a lot of room in the front compartment here, and where I've not got the gearbox or the engine in, I'm going to struggle to basically work out where I'm going to put the swell pots. I've got an idea, but until I've got the gearbox here, I can't really do that. But that's the next step on the fuel system. Routing the fuel to the back of the car is going to be done through the centre of the car in the tunnel, which is going to be under the gear stick. You can't run fuel lines outside of the car under it like you would in your road car. Reason being, if the car goes off circuit and goes into a gravel trap, then it's likely that the fuel lines will, you know, break and obviously disperse petrol, which I've been told is flammable. So you have to run the fuel lines inside the car, but not in the cabin. They prefer it if they're housed in some sort of system, be that a duct, be that in the seals. But obviously in our case, we've got a centre tunnel which we can put the fuel and also the brake lines in. So that's the next step.
To show us the tank and tell us how that whole system will actually work.
We've gone for a fuel cell, where a fuel cell is effectively a cell of fuel housed in an aluminium casing. So the idea of it is, in the event of a crash, if the front end is obviously compacted, this, instead of actually breaking, it's a bag, so it'll actually just sort of, it will change shape. You hope that it's not going to rupture and fuel's going to piss out. What we've also got in this fuel cell is we've got foam. So we've packed the whole cell with foam. So let's say we've got 50 litres of fuel in there. You won't get fuel surge. So in the event of going around a corner at very high speed, you won't get 50 litres of fuel go like this, and then 50 litres of fuel go like that. The whole idea of the foam is it slows that whole movement down, so you don't get weight flicking from one side to the other. The actual fuel cell, it slots in like so. Like so. And there's a variety of different methods to get the fuel in. What we're going to do is we're just going to have a gravity system where you quite literally just open the cap and fill the tank up. ATL, who manufacture the tanks, they do a variety of systems. So you can actually have a system where you lock on and you can fill the system up with pressurised fuel, so you could fill that tank up in probably 10 seconds. We don't need that for what we're intending to use the car for. We're not intending to race it where you'll have multiple fuel stops. You know, the tank might last an hour and a half, might last 2 hours, depending on the environment, and that's right now plenty enough for us. So we're not going to go to the lengths of a pressure system. We're just going to use gravity at the moment.
And by the sounds of it, you're particularly chuffed with this housing.
Yeah, I've seen some online and they have quite literally been plonked in. The shape of the fuel cell has that shape which is quite difficult to actually replicate and to put into a car and make it square. I've done that, and to make it fit perfectly with the roll cage is is something that I'm quite proud of.
So, what's next?
I've got an electronic dash, which will show all of your obviously need to know bits and pieces, which is going to be where the original dials were, but it will be obviously an LCD screen. All the little superficial bits and pieces of what I need to do next. I think the important thing is to get the engine and gearbox in, so I see what room I've got to play with regards to ancillaries, so intercoolers, exhaust systems, where we're going to mount the turbo. That's the next big thing. That has then all got to come back out. The gearbox, I've got a set of straight cut gears. Straight cut gears can basically withstand a lot more power. We're doubling the horsepower of the engine, so the gearbox needs to be stronger to basically be able to put that onto the road. Once the engine and gearbox are back, it can go back in, and then we could start doing all the other bits and pieces, which is not going to be easy, but that'll be then.
Would you say that you're on schedule?
There's been a few delays with regards to the engine. An example is a clutch plate, although that's part of the gearbox, you could argue, but I had to wait 20 months for a clutch plate to arrive. It's a special clutch plate, and it's got some quite special materials which will be able to accommodate up to sort of, dare I say, 1500 horsepower. Not that we'll ever be making 1500 horsepower, but there has been lots of delays on the engine side, and of course we can't do anything else. We can't do ancillaries, we can't do exhausts, turbos, intercoolers, wiring looms until we have an engine to work with. So we have got everything for the engine now. It's just actually building it so it is an engine. We can put it in the car, and then we can actually dare I say see wood from the trees. Not sure yet, but it's better than a big empty hole right now.
What amazes me is William's knowledge around putting a car like this together, and also at the same time the attention to detail. I love the air jack system and the fact that he's hidden it and made it really unique in its design. The attention to detail as far as the height of the driver and the position of the driving seat going back, and the adaptation or adapting the linkage to the gear stick so that it's still right next door to the steering wheel. It's just awesome, really, and it's fascinating. I also love the fact that even though it's not a massively old Porsche, it is being brought forward with modern technology like drive-by-wire and all of that you know, all of the bits on the suspension and everything. So when the car eventually is finished, it will really stand out and be a competitive vehicle, you know, in the lineup. I hope you've enjoyed watching this film as much as I've enjoyed making it. I find this whole thing fascinating. Please subscribe, like and subscribe, that would be great. And also look out for this particular playlist. There will be more episodes on this build. So in the meantime, thanks for watching, and I'll see you in another one. Bye bye.